All right, this will be the video guide for the mass-to-mass stoichiometric problem worksheet. First thing you're going to notice, we have the exact same formula as the previous mass-to-mole, mole-to-mass worksheet, so I'm not going to spend a lot of time talking about balancing. I'm just going to do it. Let's see, we got a 2, a 2, and a 3. Okay. What's the deal with these is that because we're all starting with mass and we're going to mass the other one, these are all going to be three-step Stoich problems. So essentially, we're all going to have to start out with since you're starting with a mass, you need the molar mass to get to moles of the known, then the mole ratio to convert from moles of known to moles of unknown. Then you're going to take those moles and use the molar mass of the final product to determine its mass. Okay, so 3 steps. Okay, so on this one, we're starting out with 25 grams of potassium chlorate. Okay, and we're trying to go to grams of potassium chloride. So, first thing we have to do is we have to take these grams and make them moles. Well, whenever you're doing molar mass, it's always 1 mole potassium chloride. If I add up 1 potassium, 1 chlorine, and 3 oxygen, it ends up being 122.55 grams of potassium chlorate. Grams of potassium chlorate are gone. I now know moles. Now that I know moles, I'm ready for my mole ratio. According to the formula, for every 2 moles of potassium chlorate, I get 2 moles of potassium chloride. Moles cancel. But I did not ask for moles of potassium chloride, I asked for grams, so I need its molar mass. 1 mole of potassium chloride weighs 74.55 grams. That's if you add up 1 potassium and 1 chlorine. I'm ready to solve. I would take 25 times 74 divided by 122. When you do so, your calculator is going to spit out 15.20807834. You're going to be limited to 2 sig figs, so it's going to be 15 grams of potassium chloride. Okay, on this one, it asks, first let's balance. We put a 3 here and a 2 here. How many grams of hydrogen are necessary to completely react with 50 grams of nitrogen? Well, once again, we start with what you know, 50 grams of nitrogen. Okay, 3 steps again. So I know that for every, I need to find its number of moles. So every 1 mole of nitrogen weighs 28.02 grams of nitrogen. Grams cancel. I now know moles. I'm ready for my mole ratio from the balanced formula. For every 1 mole of nitrogen, looks like there are 3 moles of hydrogen. Moles cancel. Now I need to know the molar mass of hydrogen. Once again, it is diatomic, so it's not 1.01, it's 2.02 grams of hydrogen. Moles cancel. Okay, so I'm ready to solve. I'm going to take 50 times 3 times 2.02 divided by 28. When you do so, your calculator is going to spit out 10.813745. We need 3 sig figs, so it's going to be 10.8 grams of hydrogen. Okay, the next part says how many grams of ammonia are produced. Once again, you could use this result, but I would strongly suggest you don't, because if you fat-fingered something, even if you set it up correctly, it's going to make the next answer incorrect. So I would always start, if I have the option, with something that was given to me. Okay, so once again, I'm going to start out with 50 grams of nitrogen, and I need to make those into moles. So 1 mole of nitrogen still weighs 28.02 grams. Grams cancel. Now I know moles. Now I'm ready for my mole ratio. According to my balanced formula, for every 1 mole of nitrogen, it appears we have 2 moles of ammonia. Moles of nitrogen go away. Now I need to do the molar mass of ammonia. Whenever I'm doing moles and grams, it's always 1 mole. 1 mole of ammonia weighs 17.04 grams of ammonia. Moles cancel. I'm going to take 50 times 2 times 17 divided by 28.02. When you do so, your calculator is going to spit out 60.8137045. Okay, well, we're limited to 3 sig figs, so it's going to be 60.8, and this is going to be grams of ammonia. My pen's kind of crapping out down there in the corner for some reason. Okay. All right. Last set here. We got a balance. 2 goes here. 2 goes here. Okay, so how many grams of silver chloride are produced from 5 grams of silver nitrate? So start out with what we know. 5 grams of silver nitrate. We need to make these grams into moles. Molar mass. So it's always 1 mole. 1 mole of silver nitrate weighs 169.88 grams. Grams cancel. I now know moles. I'm ready for my mole ratio. According to the balanced formula, for every 2 moles of silver nitrate, there are 2 moles of silver chloride is what we were asked to find. Now all I need to do is its molar mass. Once again, only 1 mole when you're doing moles and grams. For every mole of silver chloride, it should weigh 143.32 grams. Moles cancel. 5 times 143 divided by 161. When I do that, you're going to get, I'm just going to round it, 4.2 grams silver chloride. 2 sig figs. Last one, it says how much, let's say how many grams. Once again, I should have said grams. But how many grams are necessary to react with the silver nitrate? So once again, start out with what we know. 5 grams silver nitrate. And I know every 1 mole of silver nitrate still weighs 169. This is supposed to be a 9, then my pen crapped out there. 169.88 grams of silver nitrate. And let's see, I know that now I know moles. Now that I know moles of silver nitrate, I can convert that to barium chloride moles. Let's see, mole ratio, 2 moles of silver nitrate is 1 mole of barium chloride according to the balanced formula. Moles cancel. Finally, molar mass of barium chloride. For every 1 mole of barium chloride, it weighs 208.23 grams. Barium chloride, moles cancel. 5 times 208 divided by 169 divided by 2. When you do that with sig figs, 3.1 grams of barium chloride.